into enterprise software, learned some like enterprise Java. It was funny, like when I first started coding Solidity, people always made fun of me because I coded it like Java,
Java.
and I still do a little bit, but
Like
you know,
conventions, yeah.
but yeah, I'm much more like Solidity native now. Um, I had the idea for Fei protocol as I was like degenning around in some algo stable coins back in 2020. And then I went to launch Fei. That was a whirlwind. We could talk a lot about that, but I'd much rather focus on the ERC 4626 spec because that's like a pretty exciting thing that we're pushing right now. And yeah, we're doing a ton of other cool stuff in the tribe. We just merged with Rari Capital. I collaborated with some of the Rari devs on the specification, Transmissions 11 and Jet. So yeah, like it's been a pretty like compressed journey as it has been for a lot of people and really exciting. And I'm pumped to like be able to be writing an ERC that I think is going to have a really cool impact on on the space. And yeah, it's really exciting to share that with you guys.
That's awesome, man. I know quite a few people actually who sort of got into the Solidity space, I guess, coming from a Java background. And at first, I'll often, yeah, I think people like have issues with their style, but then like they take off and they become such great developers. So it's actually quite an interesting correlation, even though it seems that the styles these days are a little different from like what Java recommends. Um, Sweet. So I was going to ask, um, can you give us a sort of an overview of the standard, um, and at a high level, what it does, where it's useful, and how you see it sort of playing out, being adopted, and changing DeFi as we know it?
Yeah, I'm happy to. So the original idea for the spec was a yield bearing vault. So basically, any token which like accrues interest in a native token. So you have like kind of three different classes of yield bearing tokens. You have um, like lending markets like Compound and Aave, and then you have yield aggregators, which aggregate various different yield sources and strategies, like Yearn and Rari Vaults and Idle Finance. And then you have like intrinsically yield bearing tokens like XSushi or Geom, where they're just like rebasing in an underlying asset through like some other kind of value accrual mechanism. And you can already see that those are like some pretty diverse use cases. And there is no standard interface for a token which generates yield. And so that just makes it a nightmare for integrators at every part of the stack. And I think a lot of people think that this is just a problem for yield aggregators, but it's actually a problem for like, you know, lending markets like Fuse, which might want to plug in collateral, unlent, unborrowed collateral to other yield sources. They can't do that without like custom connectors all over the place. And same thing with Balancer. Their strategy for V2 is to have asset managers which can rehypothecate capital outside of the liquidity range that they're in. They also need to develop custom connectors for everything. So the industry is like exploding because it's greenfield, but there's no standard. So everyone's just wasting developer time and resources. And the cool thing about the standard is that it's completely backwards compatible with every system that I know of. And so we can just develop single adapters to the standard, and developers can immediately start coding for the standard, and we can retro everything back in. And then eventually new versions like Yearn v3 and, you know, Aave v3 or v4 or whatever, like those will all use the standard. But in the meantime, we can retro everything back into it. So it's just like a no brainer and an immediate time save and developer
I mean,
save for the,
it could
yeah,
also be used as a
exactly.
middleware, though. No, like if Yearn wanted to keep a Yearn vault structure, at least they could also provide like a 4626 like wrapping to be
Yeah,
called. No.
exactly. That's kind of what I meant by the adapters. But yeah, middleware is an
Ah,
even
okay.
better analogy. Like, yeah, you can wrap kind of anything. And then what we realized was actually like you don't have to be like a monotonically increasing yield generating strategy to use this interface. It's really any vault that is just token in, token out. So you could have lossy strategies like ribbon vaults. You could have like yield farming strategies where the yield token is a different token, like convex. So we renamed the standard. It was originally the yield bearing token vault standard, but now we're calling it the tokenized vault standard. So we're just keeping it very abstract on like what exactly the standard is doing. It's just an interface for depositing and withdrawing a token from any kind of strategy, really, that handles a single token. And we got some great feedback from some really awesome people in the industry to kind of make this a really robust spec that can handle a lot of different use cases in an elegant and minimal way.
The question is if Maker will ever use it if you don't name it something like the Fropple.
Yeah, I mean, we're pretty bullish on maker names at the tribe. So our new product Turbo uses a bunch of fun maker names like Gib and Slurp. So I think like we'll see if they use it.
All right, awesome. I mean, the nice thing about this space also is even if Maker doesn't, someone else can always launch it as middleware functionlessly. So
yeah, exactly.
I mean, cool. So what do you say, Ben? Think we should dive in?
Yeah, I'm keen. I'm very keen to get into the code here.
All right, so let's take a look.
All right, so we're starting off here on the actual interface. It's just
all right, so
ERC 4626. How do you say it, Jody? By the way, do you say 4626?
Yeah, I say 4626.
Okay, 4626.
4626.
Having that
like
sixth iteration right there.
Yeah, so it was funny. We were actually debating whether we should try to wait for like a better number, and we were like, maybe we want it to be like divisible by 10 or something. And then we were like 4630, like that's cool, but it's not that cool. And then we realized like the next PR was 4626, and we were like, that kind of rolls off the tongue, you know? Like,
yeah,
so we just went for it, and I'm actually like pretty attached to it now. I like it.
There's a funny little piece of errata in EIP1 actually that if the editors think that somebody is trying to mine a number, like they're like making kind of garbage PRs so they can get a certain number, that they have the right to confiscate that number from them. But I mean, it's like waiting for one to pop up. It's hard because there's so many non-EIP PRs there, and then the PR number is the one that becomes the EIP for people who aren't familiar with the. But yeah.
There's some funny history around EIP 4444. You guys should go like read the resolved comments, like unresolve them and like take a peek at them. They're pretty funny. Like the editors are like always going at each other about like, you know, getting cool numbers. It's pretty funny.
Yeah. It sounds like it's been a big issue in the past. I don't have the history on it. Yeah. Cool. All right, so we got two basic events here. Deposit and withdraw, you're indexing the addresses over there, but not the values. I mean, I'm assuming that basically if you're building a subgraph or something like that on this, you're very likely going to want to be able to search by address. So that makes it a really easy target for indexing. But searching by a particular value sounds a bit weird. Like, you know, you want to get all one token deposits or something. So I'm assuming that's why you left off the indexing over there.
Yeah, as a general rule of thumb, I usually just always index addresses if possible, and I pretty much never index integers. Addresses and bytes, anything that's like an identifier is something I would index, and anything that's like a value type, you would not really index.
What if, so there might be an edge case, what if it was like an ID, but an integer ID? Would you
of course.
that?
I mean, like the Governor Bravo uses integer IDs, and so in that case, yes, you would index it. So that's kind of what I mean. It's like that's like the general rule of thumb, but really the practical reason is if it's an ID, you index it. So if it happens to be an integer ID, then yeah, like you said, Ben.
Awesome.
All right. So then looking into the functions, we have deposit, which returns the amount of shares. So, I mean, basically, again, just speaking this out for anybody who's not so familiar with these structures, anytime you've got a token, like say Sushi, for instance, where you're buying the Sushi platform, you're getting back another token called X Sushi. So then basically your deposit is a percentage of all of the sushi that's in the pool. And then the X Sushi that you're getting back to some degree represents the amount of shares that you have in that pool and the dividends that are divided to it. So for instance, in Sushi's case, you've got sushi in the pool. You stake some sushi, you get some X sushi back. But as Sushi Swap itself accrues more sushi, they distribute that into the pool, and it's distributed proportionately, so that if you are some super whale and have 10% of the pool, you'll also get 10% of every distribution of sushi that's coming into the pool. I mean, assuming it remains a static 10% there. So that's why over here we're seeing a returns shares, I assume, is, and you're getting your X sushi or whatever it would be back. And then that's just representative of how many shares and any dividends that are distributed or change to the amount in the underlying token that you have a stake in. So is that right?
Yeah, that was a perfect explanation. So we just formalize and, put in the spec this concept of a share, which is used very extensively. It's the predominant, Yearn uses shares, Compound uses shares, Xsushi uses shares. So we like that. We kind of made that a first class part of this spec because it's such a common implementation.
Cool. So then withdraw also. So withdraw works by saying the amount of the underlying token that you want. So for example, with to carry on with this example, you talk about how much sushi you want to withdraw, not how much X sushi you want to put back in. Correct?
Yeah, exactly. And this is actually if you look at the PR, there's some debate about the naming. The reason why we went this route, and we actually feel pretty strongly about it, is that depositing and withdrawing are inverse operations conceptually. And so they should be operating on the same value type, which is the underlying. But if you look at, for example, the Yearn interface, withdraw uses the shares, not the underlying. So this would be confusing if you're used to the Yearn style vaults. But we feel that paradigmatically, deposit and withdraw operates on the underlying, and then minting and redeeming would operate on the shares. And we don't have minting as part of the spec. It was a suggestion from Alberto, so we're considering it. But yeah, that's the idea.
ERC 20, ERC 721, and 1155 all don't do mint.
Yeah, exactly. So we probably won't either. But there's a good argument for it. So yeah, if you have any opinions and you're watching this video, you should go comment on the PR.
Yeah. Just a side thing. This is kind of a funny question to ask, but the interface does compile. So
it honestly might not.
Because I think the functions need to be external.
Yeah. So if you scroll up, this is actually an abstract contract. It's kind of mislabeled.
Interface. So, okay, there we go. Yeah, okay.
Because it inherits from the Soulmate ERC20 implementation, which is like an actual contract, which you can't do with an interface. Gotcha. So I just made it abstract.
You probably should drop that I though, to be honest.
Yeah, you're totally
the I usually does mean interface.
It's incorrect. Yeah, I mean, if you read this class, it's an interface, but if you compile it, it's not. So yeah, we'll take the I out, or we'll use an actual interface for the ERC20.
Or an I, yeah. Does Soulmate have an IE ERC20?
It doesn't. I don't know why. But,
might need to make one for this. Yeah.
I think add one. Because I think Soulmate is now at least my go-to library. I'm not really using OpenZeppelin anymore if I can help it.
Friendship
same here. I mean, and we we want to continue that trend with the minimal ERC 4626 implementation. So yeah.
Cool. Well, I mean, hey Ben, if you want to be a contributor to Soulmate, you've got some low hanging fruit over there.
Yeah, I did. I make a PR.
Gas
the PR is going to be out during the during the call.
If Ben's a little bit quiet.
Transmissions, get on it.
Yeah. Okay. So then we have withdraw from. So it's like the transfer from, as in you're doing it on for someone else, as in you've got Alice and you've got Bob. So Alice is the one who made the deposit, then Bob is the one who's withdrawing So I assume this just takes, yeah, okay, it's the last time it requires ERC20 approval of the 4626 shares by sender. So it uses the same approval system as ERC20. And since it's a soulmate ERC20, that means it comes with 2612 out of the box, if I remember right.
Yeah, so you have permit as well in the base class, at least in Soulmate. That's not officially part of the spec, but if that
Right.
if that EIP becomes final, then we might also include it.
I think they're not including 2612 as a require, so you can always put it in as like a recommendation.
Yeah, absolutely. So definitely recommendation, even if it's not like formally recommended in the spec, because it's a great thing to add to your token. And withdraw from is actually a recent addition. I'm pushing for it after having written the router, which we're going to go over. I'll explain why I think withdraw from is really important.
It's interesting because
it is
structures, and I've wondered why it's such a big deal. So that is actually really cool. I would be really interested in hearing that.
Yeah, sorry, you cut out for a second. Could you repeat that? I'll
Yeah,
try to
sure.
handle my Wi-Fi situation.
Looking at different vault structures out there, I've noticed that a lot do put in a set of from functionality so that Alice can do things for Bob. And I'd wondered why it was so important, actually. So I'd be really interested to it if it's more organic, hearing like why it's important to have all of these like delegate transfer functions.
Yeah, it's not strictly necessary because you can replicate all of the actions with ERC20 token approval, but it is very elegant. So yeah, we'll get into that for sure. I have a pin in that one because that's my contribution that wasn't in the original Rari Vaults spec is the withdraw from. So
cool. So then we've got we're using the sushi example again. That would let you put in the amount of X sushi that you want to burn, and then get back sushi tokens, however many sushi tokens are like, proportional to that amount. And
yeah,
then
exactly.
I'm if you don't mind scrolling down a bit, Rory, I'm assuming the next one is, or wait, Ben, who's sharing? I think Ben's sharing. The next one looks like is from, just guessing from the net spec here. So that again is like the Alice Bob scenario. And then you do the view function. So you're doing your view functions after your state changing functions. If you don't mind my asking, of course, everybody's style is different, but like, why view functions after state changing functions?
Yeah,
I don't know
I
if that
mean,
was you.
I used to like, and also like I wrote these pretty recently, so these are not like frozen or anything. Like I'm definitely still cleaning up some bugs. I'm sure like, it might, again, it might not even compile, because I normally use hard hat, but transmissions 11 is like a huge DApp tools, like so I like my dev environment's not set up for DApp tools, and so I wrote it, I sort of eyeballed it, and then Jet wrote some tests, so I'm pretty sure it compiles, but there might be some weird errors here and there. So we'll make sure it's very pretty and finalized by the time the ERC is finalized, so that everyone has a really great resource for the standard. And I think it's pretty clean. Yeah, we're looking at it. I think Foundry like obviously is getting a lot of hype for good reason, so we're checking it out.
Yeah.
But anyway, yeah, like view functions after state changing functions. I mean, for the interface, it doesn't really, like, I don't think it makes a huge difference, but we can move it around. That's a pretty easy change.
Yeah.
So, well,
go for it.
I've heard people say that they like to do the view functions after their state changing stuff for the perspective of auditors, because then auditors like don't necessarily need to care too much about view functions because it's not where the exploits usually lie, and they can just sort of get to the meat first.
Interesting. Really interesting. Okay, cool. So we've got underlying for getting the address of the underlying token. So like that would be in the sushi example, sushi. You're scrolling, it's a little bit all over the place.
Sorry, it's a bit laggy. I've stopped scrolling on mine now.
Do you mind scrolling down a bit more? I can't see the functions.
Sure.
Thanks. Okay, cool. So yeah, we've got balance of underlying. Oh, which is at any given time how many, like, how many sushi you've got in the pool in total. Total
Yeah.
holdings would be the total amount of sushi that the pool would have. Um, shares. So what's this? Oh, if I want to know, given an amount of sushi, how much X sushi I would get. So this should return that.
Yeah, exactly. And then the symmetric function is right below it, and that's the last one.
Got it.
So this was so yeah, a couple interesting points about this. One, for underlying, it is enforced that it's an ERC 20. So like that address that returns should conform to the ERC 20 spec, which is kind of unique. But obviously it makes sense because it's a token wrapping vault, so you have to wrap a token, not like some random address. And yeah, balance of underlying, pretty straightforward. Total holdings, we might rename to total underlying because holdings is not like, this is the only place that the word holdings is used. So it doesn't immediately connect to the rest of the spec. So we're considering renaming that to total underlying. And then calculate shares and calculate underlying are kind of replacing the exchange rate functionality that we initially proposed in the spec. This was an idea that Alberto contributed in the pull request. And at first it was like, I'm not sure it really matters whether you use an exchange rate function or a calculate shares and calculate underlying. But then what we realized is that it's really beautiful to have these functions because then you don't actually need to take a stance on some kind of exchange rate or fixed point math. You can do like different types of exchange rate calculations that are nonlinear or whatever you want. And you just abstract that away through the interface. And if you think about it from the
Yeah.
perspective of an integrating contract, all you're never going to want to know the exchange rate other than to calculate one of these two quantities. So you might as well just use the two calculations as the interface and not like make integrators have to do fixed point math or whatever.
Yeah. Yeah. Cool. All right. So yeah, like you said, this is actually a really clean interface. I mean, we're talking about what I think that was a total of 6 state changers and then like 5 or so view functions. So like, yeah, I'm impressed. Like, it's a really easy interface just to like read, get a grip on, like, get what's going on. So
Yeah,
what do you
and
say you think we
you'll
should
see with the router, it's very clean to integrate with, which is really like what we're optimizing for here. Which is why like all the functions return the corresponding value. The share amount returns the underlying amount, and the underlying amount returns the share amount, so that when you're integrating, it's like you're really getting maximum information in like a minimal interface. So yeah, I think we're pretty proud of how it looks, and we think that it's got there because we got some experts like Alberto and people who really want to see this interface do everything that they need it to do, kind of chiming in. So it's pretty cool to see that. Like Scoopy from Alchemics is super excited about it. Like,
Oh,
I think
cool.
a lot of people who deal with like sort of arbitrary yield sources and making a bunch of adapters and stuff are like really wanting to make sure that the interface like addresses their needs,
Very
because
cool.
yeah. Yeah. So anyway, thanks. Yeah, we're pretty hyped about it.
What do you say we jump into an implementation?
Yeah, let's do it.
I'm keen.
Yeah.
Jeez. Yeah, I'd also like to add, yeah, the interface is so clean and like it just makes me want to start coding and building implementations of it. So well done on that.
Yeah, I've already written like 2 or 3, and I have another one. I was just talking to some of my devs about one that I think is going to be pretty cool. So maybe I'll tease it later. But yeah, like we're yeah, I feel you.
Awesome. So here we are on the implementation, right?
Yeah, so this is a unfinalized soulmate implementation of the interface. It's literally just a token wrapping vault. There's no strategy being done here. It leaves in some hooks for developers to go plug in their own strategy. If we get some extra time at the end, I can even show you the convex implementation that we're going to use for Faye. But yeah, like I think just going through this is like pretty ideal. So yeah, it's in Soulmate, obviously, Transmissions 11 is part of the Tribe DAO, huge Soulmate users all around. So we are, like we're trying to get this in the base Soulmate repos for everyone to be able to use just right out of the box, get all the functionality you need. And it uses all of the logic from the Rari vault. So you guys should go watch the Linum Labs Transmissions 11 and Jet went over vaults a couple weeks ago. And that was a really good overview. So you'll see a lot of familiar code here.
Cool.
Awesome.
All right. So we have storing the ERC20 token for the underlying as an immutable means that it gets passed in the constructor. After that, it can't be changed, makes it cheaper to access. Base, that's the scaling factor, I assume. So
What was
like,
that?
you know, for the base unit, I take it that's the scaling factor. Like,
yeah,
you know,
exactly.
for
It's 10 to the power of decimals, basically.
got it.
Yeah.
Oh, okay. All right. Cool. All right. So then you take in the ERC20 arguments in the constructor, underlying name symbol because you need to launch with that. Then underlying dot decimals. I didn't really actually called underlying dot decimals in the ERC20 right there on line 38. I didn't realize you could do that. That's really cool.
Yeah, I mean, you can only do it if decimals is technically not part of the core ERC20 spec, but pretty much everyone implements it. So this vault is only compatible with like full ERC20 implementations, but the Soulmate implementation does include a decimals call. So you can call it. Yeah, you got to be careful when you're calling it because there are some really weird vulnerabilities you can introduce, but because we're doing it in the constructor in an immutable way, you can like inspect your contract after and make sure that like nothing funny happened.
Oh, that's an interesting point also. What does happen if the contract has not implemented decimals though?
It would just revert. Yeah, it would just revert. It's like it wouldn't. Yeah, it wouldn't find the function selector, and if there's no fallback function, then it would just revert.
Oh, yeah, but wait a second. It doesn't have a fallback, callback, right?
But if it does have a fallback, it would call fallback. Yeah.
So then you just get the return value from the fallback, right? So there's a good chance that could just end up blank. No?
If the fallback doesn't, I don't know if fallbacks can return data. Actually, they probably can.
I think they can. I think there's a gas limit on it though, like a really low gas limit.
Yeah, it's a super low gas limit. I'm really like I'm not as EVM level as like Jet or Transmissions, so I don't know the answer to that. But
Transmissions is getting pretty beastie over there, yeah.
Yeah. So but you would expect there to be an implementation here, and so it would just call that.
This unit, very cool. All right, so let's take a look at this. We got the events. Interesting. This is just like a random style question. You have that check contract. You can also put events in an interface. When you put events in an interface, or actually, where do you prefer to put events? Do you prefer to declare events in an interface and then leave them out in the main implementation, or do you prefer to put them in the main implementation?
Yeah, I think this is one of those things where the repo was not final, and I forgot to take them out of the implementation when I wrote the interface. So I would definitely leave them. I prefer to leave them in the interface. I wrote the interface after I wrote the implementation because people were asking for it on the PR. They were like, I don't want to read all this markdown. I want to read Solidity. So I wrote an interface. I need to link it in the PR. But yeah, I would take these out, and then you just leave the events in the interface.
Cool. All right, and then we get into deposit. All right, now we're going. Okay, so the shares deals underlying amount dot fdiv exchange rate base unit. So you're.
Oh, you know what? I think this is not the right implementation. Can you scroll up to the top of the page and click on pull requests?
Sure. Yeah. Pull requests.
Yeah.
This one.
And then updates to interface. Files changed. Try to like view repo from this branch. Yeah, I don't know why this is not.
I think it's the three dots on the side right next to viewed. If I remember right. View file. Yeah, view
There
file.
we go.
Oh, you know what? Maybe I just didn't update this function. I'll explain what I mean when you get there. So this underlying amount dot, fixed point division, we don't need to do that here. We can just call calculate shares, which is one of the
Oh,
read functions. So that's why I
right.
thought I fixed that, but I must not have for the deposit function. So I need to go change that because it's a little bit cleaner to read,
Yeah,
but it should just say shares equals calculate shares underlying amount on line
that makes
66.
sense.
Nice. Yeah.
Yeah, that makes sense.
Good
All
catch.
right, cool. Then you get the mint. It's going to mint, like, just to keep on with that sushi example, like mint your X sushi over there and that takes the address, takes the amount of shares that are supposed to get minted. So it's like just the same standard mint function most people are used to from ERC 20. You put in where it's going, you put in how much it's supposed to mint, and it does that. You mint deposit right there. Then you do the trace of the amount right after the event. And then you have a hook afterwards, after deposit underlying amount. What's the after deposit doing?
Yeah,
Should we
so
jump down to that fast?
it's an empty hook. There's nothing in there. It's just an empty
Oh,
internal
got it.
virtual function. So this is similar to the before token transfer hook inside the ERC 20 implementation in Open Zeppelin. The idea here being like, let's say I want to make it, for example, I want to make an X sushi vault that's ERC 4626 compatible. The after deposit hook would take your sushi and deposit it to the X sushi token. So like the line 74 would transfer sushi into the vault, and then line 76 would deposit that sushi to X sushi. So now the vault is atomically holding X sushi, and you're holding shares in this, tokenized vault wrapper.
As in, you anticipate that a lot of the times this 4626 contract itself will not be where tokens are held. I mean, if you're looking at a middleware kind of view, that makes a lot of sense. It's just kind of moving the tokens between A and B and C.
Yeah, for example, like we have a convex adapter. In the after deposit function, we would approve the convex booster for our LP tokens and then deposit to the convex rewarder. So that's like, that all happens in the after deposit hook if we want to do it atomically. If you want to like batch it, then you would just have a separate like poking function, so you can spare users some gas. But yeah, I like, hopefully that makes sense.
I have just a quick question here. I don't know if there's like a reentrancy vulnerability here if we're doing minting shares before the actual taking of the token.
Yeah, I think this was brought up. So we may have to add a reentrancy guard and or like reorder some stuff, but this is the order that it happens for Rari vaults. So at least it goes like line 66, 68, 74. Those are all identical logic to Rari vaults.
I see.
So if you have your, it's going checks, effects, interactions at the end. So the interaction being like transferring tokens. So like the problem is that there's a dependency, but there could be interdependencies between like line 74 and 76. And that's where there could be some kind of reentrancy. So you have to be careful. And we're gonna like double, triple check that before rolling this out, and we might have to take the hook out and just let people kind of develop their own hooks on top of the functions.
Yeah, just reasoning about it by looking at it. If you're willing to assume that the token is not malicious, as in you feel like you can trust the safe transfer from call, like if you're willing to operate on that assumption, so then at least using the token itself as a vector for reentrancy on the callback from safe transfer from, because that is a callback in it, you won't worry about being able to call mint multiple times per deposit. But then the after deposit hook itself, like, I mean, I guess the mitigation to some degree is if they're using reentrancy out of after deposit, it should mean that the transfer gets called each time. So at least
I don't think after deposit is really the problem, because I guess that would require you to be the implementer of the vault. It's more just like if there's a malicious token. But yeah, as you're saying,
if there's a callback in it, though, my concern
Yeah.
would be that there'd be a callback in after deposit, and someone would be able to leverage that callback for reentrancy, even if the implementer was not malicious.
Potentially, yeah. But yeah, I think you've got a good point in saying that, like, if the underlying token, it's probably to a level trusted, because you're creating the vault with it, and you can check it as well
Yeah.
once the construct has been called.
Yeah. And of course,
Yeah, that's the
everybody
idea.
thoroughly reads ERC 20 code before they implement a vault for it. Everyone knows that.
Yeah, of
Sorry. Yeah. All right, great. So let's take a look. Withdraw. So this is cool. Just like looking at this and see, oh, okay, so it's going to an internal. I was like, wow, they got that in one line of code. That's really cool. But since you've withdrawn, so you're referencing an internal. Okay, cool. Withdraw from. Okay, so that just has the allowance, like the classic allowance check over there. If allowance from message sender is not equal to type uint 256 max. So then
basically what's happening here, this is the same allowance check that's used in the Soulmate ERC20 implementation for transfer from. So basically what this is saying is that if your allowance is the uint max, then you're literally just allowed to go nuts, and it's never decremented from your allowance. It's like infinite approval functionally. And then if you don't have infinite approval, you have to have enough approval to decrement, and that's checked arithmetic. So if you underflow, then it reverts. And that's sufficient condition for making sure that the allowance is high enough.
It took me a second just to like get my mind back into it, but like, I mean, coming from NFT dev, it's kind of a way of hacking is approved for all into ERC20.
Yeah, exactly.
Yeah.
This is classic Transmissions 11 opinionated implementation. Like, I think the balancer code also has an opinionated infinite approval inclusion. So it's just like, I think this is a pretty popular interpretation of
It makes sense.
The ERC20 approval. But yeah.
One could argue anyway that if you're decrementing off of like max uint 256, that you're waiting for even on an 18 decimal token going to get anywhere near zero. But at the same time, actually, it does remind me there was a bug in ZK Sync on ZK Sync's bridge between Ethereum mainnet and them, where if you did not have max uint 256, it wouldn't let you bridge, which meant that you had to reapprove max uint 256 anytime you were bridging assets. This is ancient history. They've fixed it ages ago. But I remember for one of the Gitcoin rounds where they were offering ZK Sync integration, first of all, you just burnt the TX if you did a not infinite approve. And then even if you did do an infinite approve, you would have to reapprove each time. Because I was checking for max uint 256. So, I mean, the truth is it's useful for it not to decrement there at the end. Cool. So then you've got withdraw, the internal withdraw now. So you've got the shares equal calculate shares. Right, okay, fine. Only in deposit had you already calculated the shares. So here is the first time you're actually calculating the shares. You burn benefits, emit the withdrawal, have a before hook this time. Comment says you want to do a before hook as opposed to an after hook here because anytime, because you calculate where you're pulling the money from. I'm guessing.
Exactly. So this is kind of, you think about withdraw as the inverse of deposit. So when you're depositing, you're getting ERC20 tokens from the caller and then you're putting them somewhere. So in withdraw, you got to take them out of that place and then send them back. So it's kind of the inverse, logically speaking, which is why there's only a before hook in withdraw and there's only an after hook in deposit. Some people were making some good points about why we might want to put some hooks in other places. So we might do that. But
Mhm.
in terms of keeping it like minimal logically, these were like the two directions
Gas
that we thought
optimized.
made
Yeah, sorry.
the most sense. Yeah.
Uh,
Yeah.
okay, cool. We said keep on going then. Yeah. All right. So now we get to redeem. So redeem was kind of that flip side of withdraw. Instead of putting in the amount of the underlying token that you want, the amount of the yield token or whatever that you want to put back in. So that also is going to reference an internal function because there's also redeem from. Redeem from also the same allowance check. Then we have you were talking about before. You already have the few functions there, so you can just go ahead and leverage them. Then you burn based off of that, emit withdraw, have the hook, and then do the transfer right underneath that. Yeah. So I mean, like once we went through with like these things going on, it's just kind of the calculation instead of calculating the amount that needs to be burnt from the amount of shares you're withdrawing. It calculates the amount of the amount of underlying that you're withdrawing from the amount of shares that are being burnt. And then you have the 20 hooks right under. Oh, I missed one, didn't I? Did I miss one?
No, I think you got it.
I got it. Okay, fine, cool.
I think you're fine.
Then we got the two hooks over here. So before after deposit. All right, cool. Vault accounting logic. So we have balance of underlying is a particular user's the amount of sushi, so to speak, that a user has in the vault. That does balance of user, fixed point multiplication, base unit. Why do we need a multiplying
Yeah,
here?
so actually this is another case where we could use calculate underlying. If you look at
Oh,
calculate
got it.
underlying, it's the same logic. So what you're doing is you're taking the shares that you have and then multiplying them by the exchange rate and then dividing by the base unit to scale it back.
Oh,
So
right,
it's
because
just
balance
the
of is going
shares
to be the
underlying. Yeah,
shares. Right.
exactly.
Okay, yeah, I
Balance
was
of is the
backward.
shares. So this is balance of underlying. Yeah.
Very cool. Very cool. And then calculate shares would be going in the opposite direction.
Yep.
Oh, right, because you're
And
putting in there. It's not an address; it's an underlying.
yeah, so there's actually a rounding error here that Alberto found, so we need to fix that. But there's this, you have truncation in Solidity math because
Uh-huh.
you can't, there's only a fixed precision. And so fdiv and fmul are not inverses of each other because you have to
Oh.
ceiling the multiplication instead of truncating. Otherwise, you're truncating in both directions and you have rounding errors, if that makes sense. So you have to do what's called an fmul up, which ceilings the result instead of truncating.
Interesting.
If that makes sense. So that's a true inverse of fdiv. And that's not implemented in the fixed point math library in Soulmate yet. So Transmissions 11 is going to add that, and then we're going to fix that issue.
Funky. Wow.
Yeah, and there's
Today
an
I learned.
invariant that we define in the spec that this implementation doesn't hold yet, which is that calculate shares of calculate underlying of a share amount should equal the original share amount at all times. And we can actually fuzz that on any implementation of this. Likewise,
Oh, that's cool.
calculate underlying of calculate shares of an underlying amount should always equal the underlying amount. So you can kind of fuzz that these two operations are inverses of each other for any for any input, and that's an important invariant for the specification to hold.
And you can do flat out invariant testing on that. Yeah, that's really cool.
Yeah.
For anyone who wants to know more about fuzzing and invariant testing, probably the best reader I have is that DapTools talk from Transmissions. The how to be a DapTools chat in 30 minutes or something like that. He spends a while going through like what fuzz testing and invariant testing yeah, DapTools Foundry actually does build that in very, very nicely. Cool. All right, so then we have the exchange rate. So exchange rate, were you saying before, are you keeping the rate function here, or are you gonna take that out?
We're going to keep it because we need it for the implementation. We could make it internal, I guess, because it's not part of the spec anymore. But a lot of existing implementations use exchange rate, like Compound and Yearn. So we'll probably keep it. I don't know if we'll keep it public, but it'll definitely stay here because it's still useful. It's used in the to calculate functions above, so we need it. But instead of exposing this as part of the interface, we abstract it away through the to calculate methods.
Cool. All right. And that takes us really through the whole fall. So you really wanted to jump into the router also. I would say, why don't we take a crack at it? Yeah.
Yeah, absolutely.
Awesome. All right.
So
yeah.
Yeah, this is a contract that's like really special to me. It's probably not perfect, right? Or it's certainly not perfect, but it's probably not like implementation finalized at this stage because I wrote most of it today and yesterday. But
Cool.
I think it's really I think it's a really powerful illustration of how cool this spec really is. So this is a router that can take you from any ERC 4626 vault to any other vault, regardless of the implementation details, which is super
If I'm
powerful.
understanding right, that's like a zap. No?
It's a zap. It's a zap between any two vaults, period.
So like
So cool.
I have YDI and I want to turn that into YUSDC, for instance.
No, so rather YDI to any fused die or YDI or like
Oh,
sushi
gotcha.
to C sushi or A sushi or some other so it's any two tokens that are underlying that are the same. You can go between any two vault implementations around that token.
Got it. Very interesting. So in terms of rotating positions, it would make rotating positions on the same underlying asset like super easy.
And you could imagine writing a router, a 4626 router for any AMM. So what we might do is we might actually make a 4626 router for Uniswap that lets you go from a vault through Uniswap to another vault in a different token. So now you can go from one token to another. Like you don't even you don't even need Zapper anymore. Like this is Zapper. It's one router and it's immutable. If you think like that's the implication of this contract. Like obviously you still need Zapper for things like leverage. Like if you want to take out a debt position on Liquidity and then do some cool shit, like you need Zapper. But
I think a lot of Zapper's mode is also their UI.
Exactly. And so we're probably going to want to work with them. Like I'll talk to Seb and see like if they want to integrate 4626 into their front end because like we're going to need some good front ends for this. But this is the core router.
Yeah, I've been thinking before, like I just wasn't sure if I should pay attention or not, but I actually was thinking a lot about Instadap and DeFi Saver just because those in terms of like the heavy integration smart contract wallets, I would think something like this would be really interesting to them in terms of minimizing their risks. And because right now, if you look through like Instadap or DeFi Saver's code, there's a ton of just integration logic. I mean, if they want to integrate a platform, they literally have to have smart contracts that know exactly how to communicate with the platform. Being able to give them something a little bit more generic so that they're able to offer platforms without having to like redo their entire smart contract suite and like redeploy and like make a new version and everything, I would think would also be really, really powerful for them.
Yeah, I didn't even really think too hard about the interface aggregation aspect of this, but yeah, like the DeFi Savers and Zappers and Instadaps of the world could really benefit from this interface too, because they're also huge consumers of adapter integration logic that is no longer going to be necessary after after seeing the spec kind of come to fruition.
Cool. So okay, what do we have here? We have deposit to approve vault.
Oh yeah, so let me explain something. So the terminology is not finalized, but you can think about it like this. There's two kinds of vaults. There's vaults where depositing requires a token approval, which is like compound style. Or there's vaults which assume you already transferred to the token in the same call. So like Uniswap style. And this router is based heavily on the UniV2 router. Conceptually, like obviously there's not a lot of similar logic, but just like the way it's architected is very similar to UniV2. And so UniV2 pairs assume that tokens are already transferred in to the pool before doing any swapping logic. So there's no like, you don't need to approve every single uni pair when you're swapping. So so let me like break down the user flow to make it really clear. In an approve style vault, first you approve the vault of the ERC20 that you want to deposit, and then you call deposit, and the vault will pull those tokens from your wallet into the vault using transfer from. An optimistic style vault, we're not sold on the name yet, we might call it something else, but an optimistic style vault would assume that you already just directly transferred the tokens into the vault before you called mint, and then it would use internal accounting to figure out how much shares to send you.
Very interesting.
Does that make sense? Like the two differences there?
I'm good with it. I think that is but you'd be muted.
Sorry, you cut out there. Yeah, I'm good with it.
Oh, whoops. All right, cool. Yeah. So yeah, I'm good too. That's cool. The problem with the word at this point is that I do feel like it kind of got reserved.
It's overloaded.
For my rollups.
It's overloaded. So I think we're like, one thing that Transmissions and I were discussing is potentially calling it like an atomic vault. So instead of doing approval, it's just like you transfer and call deposit in the same sort of atomic transaction. So maybe like, I don't know, what do you guys think about atomic vault? We also thought about like calling it like a prior vault or an advanced vault, just kind of capturing this idea that like you're sending the tokens beforehand instead of using ERC20 token approvals.
I'm sitting here, I'm wondering about it. Like, I'm actually like a big stickler in conventions. I'm actually wondering if maybe I'll take a page out of like, the maker book and say that since it's so hard to find a word, maybe it's just better to have Vault A and Vault B.
I'm down for that too. There's clearly two different implementations for deposit paradigms. So I wanted to make sure that the router could accommodate for either. I don't want to take a super strong view on how we name them, but it's very clear to me that we want the router to be able to handle both cases, and we wanted the router to be able to operate between both cases. So that's kind of, that's the idea there. Yeah. And if you look at the implementation of these two methods, you'll see there's a very clear difference, and there's some clear trade-offs between each implementation.
Yeah, because I guess what's happening on my end is like with the explanation, I totally get it. But even if you'd switch like optimistic to atomic or come up with different wording, I kind of suspect it's always going to need the explanation. And if it's always going to need the explanation, I kind of wonder if like you don't want to like make people look at this and be like, optimism, why am I depositing on optimism? Or like whatever the case is.
No, and we're probably going to scrap the word optimist. I was actually debating with Transmissions and Jet earlier today about what to call this, and so we're going to figure out a good naming paradigm for it and then stick to that. And it's probably going to be something that's not overloaded, even if it's like a little bit suboptimal in terms of how it explains it. But anyway, for the purposes of like the rest of describing this contract, what do you want to stick with? Optimistic, atomic, whatever.
Just proof and optimistic.
Okay, yeah, cool. So yeah, there's two kind of deposit wrappers. These are the least interesting functions in the router. It's just a normal deposit. But then the rest of the logic is about like routing between implementations. So
actually, if you don't mind scrolling back up to them, though, the one thing I really do want to get before we move on is like having a good grasp on what the difference between the two functions are over here.
Yeah, I think it's definitely worth it to dive deep on that.
Is it just the approve step that you're sort of skipping out here?
There's one other nuance, which is if you look at the transfer from is going to the router in the approval step, and it's going to the vault directly in the optimistic step.
So this one, basically the vault pulls it in, and this one, the vault assumes that you pushed it in. So it's like pull versus push, basically. Yeah.
And if you'll notice, this is where like the interface kind of really shines. The deposit function returns the amount of shares that you're supposed to receive. So you can actually do a check that you're receiving at least a minimum amount that's passed in by the user. That could be 0. But if you want to be very opinionated about how many shares you're getting, you can check that extremely efficiently from like a gas perspective and from like just a logic perspective. Like you're checking that the return value, the amount of shares that returns from the deposit call, is less than some minimum. So that's kind of a nice like additional safety that is very cheap to add in here.
Yeah, that's pretty cool.
That's really cool.
When do you think that would be like sort of a needed? Because it's very similar to sort of like a slippage check on Uniswap. So are you sort of like anticipating kind of a front running thing going on here, or some sort of MUB?
I'm imagining that like there's certain types of lossy vaults that might actually have their exchange rates change due to external factors such as Oracle updates or even like liquidations. Like you could think about like a ribbon covered call writing strategy that all of a sudden, if like the ETH price moves outside of the strike price, now your exchange rate goes down. There's an argument to be made that this isn't really necessary to be included, but it's so cheap to include that I feel like it's worth it. But I'm gonna run this by people that are smarter than me, and we might take it out. But definitely doesn't hurt.
Yeah, I think it's a nice feature from my end. Will, are you ready to move on, or did you want to look at the?
No, let's keep on going. Just also, Joey, like I know that we were originally scheduled in for an hour. We're able to go if you're interested, also.
Yeah, for sure. I mean, there's really like I think 4 or 6 more functions, and then you double that for the permit implementations. But those are literally just the same thing, but with
same thing.
Permit. Yeah. So I'm totally down to crush the rest of this.
All right, awesome. Let's do it. Imagine Ben actually making it through everything in one sitting. We usually end up like saying we're gonna do it, and then like having to add a second week, and then just not finishing everything and being like, okay, fine, time to move on anyway. So, yeah, I think it is a testament to how minimized this code is. Like, it really is a very good minimalist implementation.
Yeah.
So yeah,
we've covered like 3 whole smart contracts at this point. This is amazing for us.
I love it.
So what do we have here? Withdraw to approved vault. So we've got the from vault. It's coming from one vault. It's going to another vault. Address to. Why is there a to address if it's going from vault to vault? And we already have the vault. Oh, so because you're just using the interfaces and you need to know where the interface is going. Okay, I got it.
Yeah, exactly. So this is kind of like if you are a DGen and you're on Uniswap in UniV2 and you want to do a add ascend as part of your swap, this is like the add ascend. So the to address is like you could go from like you could go from your DAI vault on Compound to a DAI vault on Fuse that you also send to Ben because you owed him money. So he could be like, I don't want your C DAI, I want F DAI because I'm a Fuse maxi. Like you go from vault A to vault B and you give ownership to Ben, all in the same route.
Okay, cool. Underlying amount and then shares out. Cool. So we have under ERC 20 underlying is the from vault underlying. If underlying is not the to vault, dot underlying. So then, okay, then you revert because there's a mismatch. Custom, I haven't pointed this out before, but I will throw in now. Custom Solidity 8 errors. From withdraw from message.sender to address this amount underlying. Okay, fine. All right, so that's going into the vault router. Underlying.safe approve address to vault. So you're approving that vault on amount underlying because it's going to pull it out of here. So then if to vault.deposit is less than min shares out, then revert with that error. Yeah, cool. I didn't speak that out amazingly clearly. But basically what you've got is you set up the ERC20 token, you make sure that you're on the same page, as in the vault that you're pulling out of has the same underlying token as the vault that it's getting sent to. So that way you're keeping DAI to DAI or whatever the case is. You do the withdraw, it pulls it into the router. Then you approve the destination vault on the amount and you have it pulled from the router there. I'm like just sitting here and trying to figure out if there's a way to take out that middle step. Why don't you have the to vault pull directly from the original vault?
Because then the original vault would
There's
have
no
to
way to
approve the
approve.
two vault.
Yeah,
There's no way
to
to,
make the
yeah,
approve.
there's
I
no
just
way to,
noticed that.
yeah, there's no way to do that. If you can think of something that we could add to the interface to cut that out, that'd be pretty sick. But I do think
The
like
truth is, with
logically,
permits, I think you might be able to.
yeah, but you can't permit from a smart contract. So I'm not sure if, yeah.
So I mean, you're right that permitting from a smart contract, not, but if you use, okay, I mean, I'd have to go on a massive tangent about EIP 2098 and EIP 1271, I think. Like maybe making a permit structure for alternate signature schemes. But
Hey,
that,
who knows?
yeah,
Maybe you write the permit equivalent of, going from one vault to another, and that makes it into some future ERC. Like that would be pretty sick.
I was literally thinking about writing one over the weekend to extend 2612.
I love it. I love it.
Yeah, here's the thing with 2612. 2612 splits signatures into VRS, bytes 8, bytes 32, bytes 32. That only works on, let's just call them canonical signatures, like the ones that pop up in MetaMask and things like that. There are other EIP approved signature schemes like EIP 2098, which has a 64-bit signature, whereas the VRS signatures are 65. Sorry, bytes, not bits. And then 71 basically creates an interface for there to be like a delegate signer for a smart contract. But the thing about 1271, which is kind of interesting, is it's a very open-ended signature. Like you can get a lot of weird signature schemes into 1271. I'd have to look at it again though. But both of them are like trying to address like the ability of giving a smart contract some kind of signature. I'd have to look into them again. I don't know if they help here, but like that could be something that might be worth looking into, because you're right, normally contracts can't generate. You'd have to think of some way. Yeah, all right. Maybe I'll like sit there and try and think, like puzzle about that a bit. I'm like even 1271. I don't know. Like now that I'm thinking it through, I don't know if some do help here, because there'd have to be some kind of EOA attached to it that would be able to fire off SIGs, I think. But I'm not sure. Maybe I'll try and look into that on the side.
Cool. Yeah. Yeah. Why don't we check out the withdraw to optimistic, the optimistic version of the last function.
Cool. So here we got. So again, we set up the underlying, make sure that it's the same. Then we have the withdraw from vault withdraw from. So it goes to the router. You deposit in the to vault again with the error. So the only thing that's missing here again is the approval, like Ben pointed out, and then the address destination is different. As in here you are directly to the to vault without any other intermediate step.
Yeah, so this is the same difference that we have in the deposit versus deposit to approve versus deposit to optimistic. It's you're sending it straight to the vault in the optimistic case versus you're sending it to the router in the approved case.
Yeah.
And that parallel exists for all of these pairs of functions.
Mm-hmm. And I'm guessing without looking. So now I see the next function is called redeem. So these two, the withdraws, they take amount underlying as an argument. I'm assuming the redeems are going to be the same thing as the withdraws, just with the shares. And so like basically,
I'd love to go on a quick tangent about the withdraw ones before, but you're spot on for the redeem. Like it's the same two functions, but using the redeem paradigm instead of the withdraw paradigm. So you're living in shares world instead of underlying world.
Yeah. So what did you want to say about the withdraws?
Right. So if you remember from before, we talked about how withdraw from is like not strictly necessary in the standard because you can approximate it using token approvals. But let me show you why I think it's like pretty important to include. So if you look at this withdraw to optimistic vault case, let's imagine that withdraw from doesn't exist. So we have to like re-implement withdraw from using the interface. And the way that you would do that is you would say calculate shares. So you do from vault dot calculate shares from amount underlying. And that's the amount of shares that you're going to need to pull into the router, or rather into the underlying in order to, or rather to the to vault, excuse me, sorry, I had to correct myself twice. But you would calculate the amount of shares you need to withdraw it from the caller to the router and then send it from the router to the to vault, if that makes sense. So you have to do an extra calculation. You have to call calculate shares inside, and then you have to do an extra token transfer in order to basically do the withdrawal, because you can't withdraw on behalf of somebody else. So so basically you're adding these two functions. You're adding calculate shares, and then you're adding a transfer on top of the withdrawal, because you have to withdraw from the holder of the shares unless you have withdraw from.
It only ends up being one extra. I'm sorry, the calculation doesn't end up being extra because you need to call that under the hood anyway, though, no?
Yeah, so you need to call that under the hood anyway. But here's the interesting part. So what happens if the calculate shares function is stale? What happens if you have a continuous compounding, like on compound or on yearn, where from one block to the next, you may have a different amount of value accrued, but you need to have some state change in order to reflect that in the view function. So then you're left with some dust. So if you want to be complete, you actually have to like burn that dust or send it back to the caller at the end of the function. And that makes it like really inelegant and kind of suboptimal, which is why I elected to include withdraw from, because instead of having to deal with dust or anything, you're a first class operator. If you have token approval, you can do withdraw and redeem operations as if you were the caller, versus having to like back calculate everything and hope that there's no like exchange rate rounding errors or any dust or anything. And that's why I think it's pretty important to include the withdraw from, if that makes sense.
Very cool. Yeah, makes a ton of sense. Very cool. Yeah, so just to summarize, like what you're doing is you're answering before, like why it's important to have withdraw from functions. We have wrappers that are sitting in the middle, so then it gets really important to give them the ability to natively move tokens from a point A to a point B that's not them, because of just different, like you're saying, the state changes that can accrue if it's natively implemented. That's really cool.
Yeah, exactly.
And I think
so.
Yeah.
Oh no, that's it. Yeah, I'm glad you guys see it too, because I feel like it's probably going to make it into the final spec. Like I said, we're going to run that decision by a lot of people, but I feel pretty confident that it's the right move. So it also doesn't bloat the state of the contract too much, because as you saw in the ERC 20 Vault Soulmate implementation, you're using the same internal function for doing the withdrawal between withdraw and withdraw from. So it doesn't add like too much bytecode to the contract deployment. So it's probably a pretty good trade-off to include it.
I mean, you could also look at if someone needs implementation where there is a massive increase in bytecode between the two. If anything, that's probably a sign that they actually really need it.
Yeah,
because whatever extra bytecode they're going to get there means that anything in the middle would have to implement themselves.
Right. And if you didn't include withdraw from, you would still be compatible with 90% of use cases. So it's not like it's like totally strictly necessary to include it, but it is probably going to be a required part of the spec if it does make it into the spec at all.
Cool. All right, awesome. So let's take a quick look at the redeems then. So again, from manage shares instead of underlying shares out. Check to make sure the underlying is the same. From vault, redeem from instead of the withdraw from. Then the safe approval to the revert. Then I'm assuming the optimistic got the same basic structure, just sending it directly to address vault. And then the if check again, just to make sure that you're getting at least min shares out.
Yeah. It's the same kind of paradigm between approve and optimistic. I want to highlight yet again another place where their interface really shines here. If you see like the amount underlying is returned from the redeem from call, and you can use that directly in your approval and deposit logic. Instead of having to calculate the underlying beforehand, it's just returned from the redeem from call, which is pretty nice, because then you know how much you need to approve without doing any fancy math.
Very cool. Very, very cool. All right. Awesome.
Yeah, so
Man, like
the
I
more
almost don't know what to do when I finish a contract now. Because we never finished the contract.
Yeah, so we're there. I mean, the permit implementations are literally just the same 6 methods we just looked at, but using the ERC 20, or not ERC 20, but the permit
2612.
extension. Yeah, exactly, 2612. And this is a straight fork from the Uni v2 router. So it uses the same approve max bool and
Oh, interesting.
permit logic.
Very cool.
that's
All right,
awesome, man.
awesome.
I like just this point here that you were making. It just like shows how elegant the 4626 standard is. Like I'm just getting much more of an appreciation now that you guys are like diving deep into it.
Yeah, and a lot of this stuff honestly was kind of emergent. Like, obviously transmissions and Jet did a lot of kind of back and forth debating about the Rari Vaults interface. And so I think the kind of these nice little final touches that you see are things that we realized from implementing things like the router. So I could summarize kind of the differences between the 4626 spec and the original Vaults implementation, because there are I think 3 or 4 that are noteworthy, and we've touched on them all. So the first one is that withdraw and deposit take a 2 address. That wasn't included in the original Rari Vault implementation because transmissions and Jet were really hyper optimizing for gas. So they were like, if you want to do anything fancy, you're going to do that at the at some kind of abstraction layer on top of the vaults. So they didn't include this concept of depositing on behalf of somebody. But then what I really convinced them of is if you think about one layer above, if you think about routing implementations, you want to have the ability to deposit on behalf of someone as a router. You want to have the ability to know how much shares you received after depositing, or know how much underlying you received after redeeming. So we added these return values in order to make use cases like this just like super seamless. So what I was really convincing them of is think about the routing layer, think about the integration layer when you're thinking about an interface. And then they realized just these 2 little changes made it so much more elegant. And then what Alberto showed us was that using the calculate shares and calculate underlying, instead of being opinionated about having a fixed point exchange rate, also makes it just extremely elegant for use cases about like knowing how much underlying you need for some some implementation. And then like we already talked about the redeem from as well, that wasn't included in the original spec. So there's all these nice little touches that I think really make this kind of a complete spec that we found just by playing around with it, reasoning about different types of vaults. And like I'm sure it'll change 1 or 2 more times, but I feel like we're really converging on something that can be a really great specification for Ethereum.
I just want to point out that this is like what I find so beautiful about DeFi is it's so collaborative and so rapidly iterative. And like as you say, it's like these properties are emergent when you just start plugging things together and building things out. And we've had it's just like DeFi has just been around for I guess like 2 years now, maybe 3. But we have so many iterations that you can look back on and be like, okay, so this is what was needed. These are all these standards that are fragmented and not really compatible in the same way. And then you throw this together, and these emergent, like beautiful properties come out, and then you collaborate with everyone on Twitter and on GitHub, and you just like it just refines these beautiful standards. I don't know. I just find this beautiful, and I'm like kind of rambling about it. Sorry.
No, it's awesome. Yeah, I mean, everyone's really pissed at me because I keep talking about 4626 too much. Like I'm like so proud of this. And but yeah, it's awesome. And I learned multiple things on this call with you guys. Like I'm gonna go talk to Seb from Zapper immediately after this call and tell him about how cool this router is gonna be and have him integrated on their UI. And like I wasn't thinking about that before. It just shows like there's even more to this than the authors of this spec knew when they set out. And I've been learning new things about it every day. So yeah, it's awesome.
Cool.
Like I can't wait to see
Yeah.
what people do with this.
You should know also, if you want your EIP to get traction, you do have to shell it. It's just the way it is. So, like, go out there, be proud of it. I don't even know if you noticed, I copy pasted your, this is like the peak EIP. It's going to change the Ethereum thing on Twitter, because I have an EIP that doesn't have amazing traction. And like when Annette especially was like, this is what you have to do to get your EIP out there. I was like, there you go.
Dude, I'm no joke. I'm gonna launch a 4626 NFT series, and each one's gonna cost 4626 stable coins, and we're gonna send all the funds to like the ETH core devs or something. But we're gonna do whatever we can to hype this thing. Like,
awesome. Awesome. If you're looking for a destination, Gitcoin matching price your easiest option.
Yeah. That was like one of the suggestions that we really liked. I also I want to plug Trent's project, Protocol Guild. I think it's kind of exactly what I was thinking
for something
like this.
Yeah, I forgot about that one.
What they're doing is they're trying to make like a, so when I think like as a DeFi founder who has, been blessed by the Ethereum ecosystem, like all I want to do is make sure that the Ethereum ecosystem thrives, and no one's more important than the core devs. And they're like, we're standing on the shoulders of giants, and all the fun and tokens and yield farming, like that's all because of the hard work and the blood, sweat, and tears of like an absurdly small group of people. So we need to trickle as much value back to them as possible. So Protocol Guild is literally like a DAO that is sole purpose is to do that. And what I like about that over like a Gitcoin matching fund is that Gitcoin's kind of a black box. Like if I'm going to go match a bunch of grants, I have no idea what grants are going to get funded. It's not very specific. And I'm not sure about curation or anything like that. When I go to Protocol Guild, it's like Ethereum OGs who are going to like fund the crap out of Ethereum OGs, and like, that's what I want. And, like people like Tetranode and so on, like really excited about this. So TLDR, like, yeah, I want to make a ton of hype about this standard. And I want everyone who's like so grateful for this standard to think about why they get to be grateful for this standard. And that's like the Ethereum core devs. And so that's where we want to like send all the value from this back to.
Cool.
All right. So that was a totally unrelated rant. I also want to plug that I got 4626.eth and I'm really excited about it. So,
excellent.
I'm gonna probably point the router to router.4626.eth.
Very nice.
And we're gonna do some vanity mining so that it starts and ends with 4626. Like we're really gonna go hard on the meme, dude. Like 4626 is my new favorite number. If you look at my Twitter handle, it's 4 + 6 equals 26.
Equals 26. Took me a minute to
PR campaign going, hey.
Yeah. So that the meme there is that like since the merge we had the like 1 + 1 = 3 meme, which is like the sum of the parts is greater than the whole kind of thing, or the whole is greater than the sum of the parts. So we just like sent 4 + 6 = 26 as like kind of a double meme where we are memeing the standard and memeing it's like way, it's like 10 = 26. It's like that's like huge gains.
Yeah.
I love it. Memes all the way down.
Leveraged memes.
Yeah, exactly. And then the other cool thing that we're going to do is we're going to probably make a repo with like canonical 4626 middleware so that, the Aves, Yearns, Compounds of the world, like you make one wrapper and then you're done. And now everyone like can just look at this repo, and we're probably going to use ENS for that too. Just really make it like so easy to adopt this standard. Like I want it to be like the greatest developer experience for this. So that's what we're going to try to leverage all the tools to like, really get it across the line in a nice way.
I think it's probably a good place to wrap. Was there something else you wanted to add? Sorry.
Yeah, I was gonna say, dude, if you guys want to write 1 or 2 of those wrappers, that would be very much appreciated, and some cool PR around this. Like if there's a protocol that's near and dear to your heart, then maybe XSushi. It'd be cool if you guys wrote the XSushi one. That's a super simple one. Just because we like talked about XSushi so much on this call.
Yeah. I'd be down to write the XSushi one if you will. If you want to do that as a little side project.
Let's talk. Let's see, man.
Yeah, just pull. Well, once it hits soulmate, once the vault hits soulmate, you literally have to like implement 2 transfer hooks, and I think you're done. Like it's very, very, very simple.
Yeah. Let's see about that. Awesome though.
Anyway,
So
yeah,
this probably
but
a
yeah,
good place to
totally
call it.
great going over this with you guys. This was awesome.
Yeah, listen, thanks for coming. This has been like this. Um, yeah, awesome stuff here. And so I guess just in terms of wrapping it up, if people weren't familiar with you before, Joey, so they can find you on Twitter at Joey Santoro, right?
Joey 2 underscores and then Santoro.
There we go.
I tried to buy a better handle, and I don't think I'm cool enough yet for that. But if you know the Joey Santoro or Jay Santoro on Twitter, I want their handle.
Good luck.
It's, yeah, it's Joey 2 underscores Santoro. Yeah.
All right. Yeah. And awesome. All right. So this has been another awesome episode of Solidity Fridays. We'll sign off over here and catch us next week or anytime as we try to fumble our way through more Solidity code.
Yeah. Thanks so much.